Original distance. This can be blue. I'm just choosing random colors here. This can be the image. Image, if I can remember where the B key is. Nope. What'd I do? Is that just from adding this line? Okay, so that works. Adding in one for V. I guess that breaks. Maybe I shouldn't open them inside them. Yeah, I guess it split up this tech part. Do I care enough? I don't think I care enough. I honestly... I will deal with that later on. For now, I'll just leave it there. Okay. So that at least runs. Now, I have to add another one of these arrows. And that's this. I'm going to do almost the same thing with the image. This will be image this arrow, arrow. It's going to go to the right. So this isn't tracked by a tracker. So I can't just use a tracker here. What I'm going to have to do is... I wonder if I can update a global variable from this updater. Or not from this updater, but this updater. It's the object instance. So... Probably being too pedantic about this. Oh great, you got reviewed. Won't that blocky lens not really reflect that way? Yeah. I just don't know how to make the sides curved that easily. But I'll learn it one day. I'll get there. So I'm gonna say image lens just this is gonna go to 0 first, then I'll try to update it here. No, that's not working. Dang, I wonder if it's possible to do. Maybe like non-local or something? This is probably bad Python. I guess it worked. It's not gonna try to print this from this. You know, it's just arrows this. Yeah. Then this will be right times image lens dist. Original dist arrow, image dist arrow, add updater. Wait, that's non-local, so the same as global. I don't know. Probably not. Wait, oh wait, I wasn't supposed to update that. I think it worked. Non-local is something I just vaguely remember. Where is the documentation? All right. Not a current global non-local statement in the current book of block. Identifier. Okay, are you gonna tell me what non-local? The non-local... Wait, what? Non-local scaling calls the list identifiers to refer to the previously bound variables in the nearest enclosing scope and excluding globals. So that's the difference. So that means it's just, I guess, going to continue looking in enclosing scopes until it finds one, not including the globals. It's probably bad code, though. I probably shouldn't have to do this. Oh well. Okay, so that color. Original dist arrow. Image dist arrow. Yeah. That isn't an arrow. Wait, why isn't it? Why doesn't the arrow have a tip? Image dist arrow to add up there. Update this. Where's the tip? Weird. Wonder what happens if I don't update it. Update image dist arrow not defined. That's true. And then it just doesn't appear. Wait, why wouldn't it appear? Returns image. Oh, this starts at 0. Okay, because it starts at 0, I bet it computes the length of the tip based on 0. And then later on, it doesn't recompute it. So if I just make this some number. That's Manim for you. Okay. Okay. So, that makes sense to me. The question I still have is, how would this work if the distance to the image was kept fixed? And you'd have to change the width, you'd have to change some property of the block, of the lens. Because in your eyeball, wait, there's another equation that describes this. Is it this one? Not that one. This one, the thickness of the lens affects the focal length. And that is one complicated equation. Your arrow for the image needs to scale according to the magnification of the lens. The arrow for the image needs to scale according... Okay. I think... So right now, I'm just using this equation alone. And I haven't made any assumptions about the equation of the lens. Or the power of the lens. Right now, I'm just assuming the power of the lens is 1 over this, I guess. But I need to unpack that more. Hold on. Hold on. I have to say this doesn't matter. Arrow size. Now this focal length, I have to write out another equation. 1 divided by u plus 1 divided by v equals, it equals 1 over f, but 1 over f is equal to this thing. So I'm going to say this equals n minus 1 over r1 minus 1 over r2 plus n minus 1 d over n r1 r2. Close. Magnification is negative v over u. So the second arrow scaled by this factor. Oh, okay. I see what you mean. So the height of that, oh, what did I do? This arrow should be growing and shrinking, is what you're saying. Which is totally true. Okay. So update original, indicate the distance to the original, indicate the distance to the image arrow, update the image here. I do mob.getCenter. This is the image arrow. Is this a vector or an arrow? Image arrow is a vector. I don't think that'll matter much. Okay, so I'm gonna say magnification equals negative v over u. I just have regular v over u. So that's gonna be, I forgot what I even had for you. Was this image lens dist? Then there's object lens dist. Which one is which? This is why these variables are so bad. Distance from the lens to the image v. Okay, so this one's v. Divided by magnification is this. I'm gonna move the object. Then, oh, because it's a vector, I don't think I can do put start and end on. All of these should just be arrows. That's what I'm gonna have to do. Hopefully that's the same thing. Perfect. What? Origin up. Why is it so small? Man. Manim is so bad. Self.buff equals buff. Buff equals 0 by default. Oh, this is a vector. For arrow, the buff is medium small buff by default. So maybe I can just put the buff to 0 here. Okay. So now, here's the magnification. I do mob dot put start and end on. This is gonna have to be its X offset. Oh, image X offset. That's gonna be this. Then the start is gonna be image X offset. It's gonna be right times that. And the end is gonna be right times that plus down times magnification. I need to get my professor start using Manim again. He's used the 3B version in the past. 3B version in the past, but hopefully with the improving documentation on community version, he would get into it better. That would be really nice if professors did that. Okay, this arrow tip looks too weird. So what I need to do is, don't do this. Okay, so this is where it was before. What did I do? I'll just scale it. So I'll just scale it first. But I want to scale it from 1. Would it be like I by mom dot get height? Why is the arrow tip? Okay, that arrow tip is just making me angry. No. Scale it, move it. Okay. I think I want to move to. Okay, so I can move to there, then I want to do mob.align. Not align, I want to move it down to the origin. I should have left it how it was before. I didn't know the arrow tip would be that weird. Here's the mob center. I won't scale it. I'm gonna do the put start and end on thing. Wait, where's the center? This. Image offset. And then right times image offset plus up times. Okay, I'm just gonna do it this way. And that should be down. Cool. I will deal with the arrow tip later. What was I even doing? Oh, I was solving that equation. So let me put that there. And then basically I want to isolate for the thickness here. I'm gonna maybe I'll just set these radii to 1 or something like that. Because I want this distance, the V distance, to stay constant. So if I solve for D, I'll have... It's times like this when I wish I had a pencil and paper. Or like a pad. Divide by n minus 1. Then I get this. That minus that plus that. Okay, subtract this over. So it'll be plus minus 1 over R1 plus 1 over R2. Wait, I should do that on a different line. Minus 1 over R1 plus 1 over R2 is this. Divide by n minus 1 again. Let me make this smaller. Divide by n minus 1 again. So then this is divided by n minus 1 squared. And this is just divided by n minus 1. Then multiply by that. Multiply by this. And this is the thickness. Now, the question is, when U increases, what is the difference in D? Well, there's a 1 over U here. It says U increases, this quantity is going to get smaller. So D will decrease, so it'll get less thick. I should double check that probably. Your eye looks like this. There's a fixed V. V can't change, so when the eye is viewing a distant object, the ciliary muscles are relaxed and the focal length of the lens at its greatest. When the eye is focused on a near object, the ciliary muscles are tense, changing the shape and reducing the focal length. But does it get thicker? When the eye is viewing a distant object, the focal length is at its greatest. That means 1 over f is at its smallest, which means this is at its smallest, which means D is smaller. So the lens, if I'm following this right, the lens in your eye becomes less thick when you focus on something further away. Which makes sense since D is proportional to 1 over U. However, this equation is way too complicated for me to want to actually... What I'm just going to do... Maybe I'll just make it smaller by some random amount that's proportional to 1 over U. That's probably what I'll end up doing. Yeah, sure. Constant V. I guess it might be sort of hard to show within equations if the equation is this. I hope I don't have to solve any LaTeX. Maybe I'll just show the solution or something. But this time, I'm going to have something similar to this. However, the lens will be an oval. Which is an ellipse. Lens height. Maybe I can pass parameters to the ellipse. Here. Width and height. Do you plan on running a session on 3D scenes? Would also be interesting to see how updates work on 3D scenes. Was hoping to demonstrate how things like parallel transporter vectors along manifolds embedded in R cubed works, and it feels like this could be done via updaters. I wasn't planning to do one. Well, not in the short term. I will have to do one eventually, though. The thing with the 3D scenes is right now is that it's just so unstable again. A lot of the stability that we've been building up with the regular objects is going to change now. So we're going to try for sure. But at least in the short term, there's no plan for it. We do plan to make them a lot better, though, for what that's worth. Where did my cursor go? Great. Okay, then let me just move that arrow again. The original arrow, then lens equation, arrow tracker, update original. I think I want all of this. I don't want update image though. Let me move this. Let me bring in the tracker. Where is it? Where is it? Original arrow tracker. This. Here. Move that there. And I'll play something like this. Okay, and maybe that'll just work. Nope. Mod move original tracker dot get value. I have to add the updater. Arrow dot add updater. I definitely do want the 3D, the OpenGL especially, to just be a lot better. That would be in general just better for the community. So I'm going to do now, here, this is going to update the original arrow. Then I'm going to update the thickness of the lens. Update lens down to lens updater. Update the lens. Oh, whoops, wasn't trying to do that. And this, I should do lens dot. Can you do set width? That's probably not a function. I think there's stretch to fit width or something like that. Do def stretch to yeah. So that'd be 1 over that value. So I have to get the original whatever value. So the original arrow length, or original lens distance, or whatever I called it. Arrow tracker dot get value. I'm gonna divide by that. I'm gonna spell stretch correctly. And then I'm gonna do this on mob. And hopefully, okay, so then this grows and shrinks. Let me just throw in some random constant to make it look a little better. Okay. I think this... The person said before that magnification was U over V. Or something like that. So yeah, this would still change the height. But I'll do that later. So I do have that lens moving. Let me... Here's what I'll do. Where's a diagram of an eye? Here. I'm gonna try to make this diagram. Draw the eye. Retina equals circle. I have to scale it probably by like 2. What benefits do you say there are for Manim CE versus Manim GL? I'm looking to integrate this into part of lectures next year and wondering what are the benefits of each. Manim GL, the upstream version, it's probably slightly more stable when it comes to 3D objects.